discussed about Harvard architecture. So in the case of computer architecture, there are two main important type of architectures, Harvard and Von-neumann. So as we have studied in the previous video session, that is Harvard architecture is consisting of two separate memories, one for program memory and another for data memory. So program memory is going to store program while data memory is going to store data. If we see Von-neumann architecture, that was the architecture which is mainly based on the concept of single program memory. Von-neumann architecture was first published by John Von-neumann in 1945. So this computer architecture design mainly consists of control unit to generate all the types of control signals, arithmetic and logic units actually responsible for performing arithmetic operations and logic operations, and memory unit which is storing instructions and data, then registers used for temporary storage and IO, so input output devices and interfacing to that. Basically, Von-neumann architecture, it is a type of architecture which is based on the concept of stored program computer. So here we are going to store our program inside the memory, and in the same memory we are going to store our data also. Von-neumann architecture, it is also a type of popular architecture and used in most of the computers produced today. So Intel family is mainly all the Intel processors, that is Intel x80x86 family is based on the Von-neumann architecture. If we see the block diagram of basic architecture, like CPU, which is going to do the main task of all the whole processing, where main important components of CPU are register, control unit and ALU. And then another important component in this architecture is main memory. So memory which is going to store the whole complete instructions and data also. So both data as well as instructions are stored in that single memory, and processor is going to read the instructions from this main memory and also reads the data from this memory. So whenever ALU want to perform any operation, the contents read from the memory will be transferred to the registers for temporary storage, and then operation can be performed by ALU. So basically Von-neumann architecture is relying on the concept of single memory for both program and data. So here memory is arranged in the form of memory locations. So every memory location is identified by a particular value and we call it as a memory address. So every location in the memory can be addressed by the memory address, and the size of this memory address will depend upon the size of the address bus of the processor. If it is 32-bit address bus is there, then the memory address will be also 32-bit, and every address in that particular processor is of 32-bit size. So both program and data, they are stored in the same memory in the case of Von-neumann machines, and the instructions which are stored in the memory, they are executed in a sequence. So if currently I1 instruction is executed, after that I2 instruction will be executed. So if there are no branching instructions or jump instructions, then the sequential execution will go on continuously. If we see now another important concepts in the Von-neumann architecture, like Mainly it is going to use the main important registers like program counter to store address of the next instruction to be executed. Then along with that instruction register, also there are general purpose registers. So general purpose registers are used for temporary storage of the operands on which instructions operate. So central processing unit is there, which is consisting of this all ALU, program counter, general purpose registers, all these things, all these components. Normally CPU reads the instruction from the memory, and this instruction will be executed by the ALU. So that is the main important concept in the architecture. So Von-neumann architecture combines program as well as data in a single memory unit. That is the main important feature of Von-neumann as compared to Harvard architecture. So in Von-neumann architecture, there is only one single memory bus, that is address bus and data bus, to access both instructions and data from the memory. While in Harvard architecture, there are two separate buses to access program memory and data memory. Because in Harvard architecture, there are two separate buses, one for program storage and one for data storage. So if we see now advantages of Von-neumann architecture, it is very much simple in the sense that only one memory is going to store both instruction as well as data. Because of this, it is very much simple, it is very much efficient and flexible also. So here if we see, complexity involved in the Von-neumann architecture is very less as compared to Harvard architecture. We can easily store our program and read with the less complexity in the case of Von-neumann architecture. If we see now disadvantages of this architecture, that is one of the important disadvantages, slow performance. So in case of Harvard architecture, there are two separate buses. Simultaneously instruction and data can be read. Because of that, it is much faster as compared to Von-neumann. In Von-neumann architecture, either I can read data or instruction. So this can cause bottleneck and this may reduce the performance. It slow down the performance. Also, it is less scalable also. So as the reading time to read the data from the memory or memory access time is more, because of that, the execution speed is also getting reduced. So these are the few disadvantages of the Von-neumann architecture. So in spite of this, because of its simplicity and flexibility, it is a popular architecture for the microprocessors like for x86 family. So thank you very much.